For decades, the global story of cars has followed the same script. If you want heavy muscles, you would look at USA. If you want absolute engineering precision, you would look at Germany. And for manufacturing reliability, Japan was the king. But there is a secret hiding underneath the sheet metal. If you peel back the layers of modern European luxury sedan, an American electric vehicle, or even a stadium-crushing monster truck, you won't find what you expect. Instead, you'll find a hidden mechanical and digital nervous systems built here in India. This isn't a story about assembling other people's cars. This is an investigation into the hyper-focused patents, the unbreakable components, with the massive software networks born in India's deep tech hubs. These are unseen forces that keep the world's most famous vehicles moving.
And we gotta do it something like this.
Let's start with bones, the heavy, high-stress mechanical parts that take the absolute most punishment. Think about the engine inside a high-performance German luxury car. Inside that engine, small violent fuel explosions are happening thousands of a time in a minute. To handle that extreme energy without shattering, you need flawless metal. In the past, companies simply poured melted steel into the molds to make engine parts, but the method left microscopic air bubbles trapped inside the metal. And under extreme driving stress, those tiny bubbles would cause the engine to literally tear itself apart. To solve this, a Pune-based company, Bharat Forge, went to the absolute extreme. They built a mechanical press so violent massive, it hits the metal with 16,000 metric tons of pressure. When it slams down, it hits with so much kinetic force that it literally shakes the earth like an earthquake. That is why it registers on local seismograph. In simple terms, I will explain how seismograph works. When an earthquake happens, the seismograph moves with the ground, but its heavy weight stays almost still for a split of a second because of inertia. That tiny difference in movement is what machine records. Now, heading back to the topic. By slamming hot steel with that much pressure, it squashes the metal so perfectly that there are zero microscopic bubbles left. It perfectly aligns the steel's molecular grain, eventually eliminating the risk of structural failure. Today, Bharat Forge is the world's largest single location forging facility. They are the indestructible spine of the USA and VW group with a massive chunk of global automotive world. But it's not just about the giant pressure. Sometimes global giants rely on tiny, zero-defect perfections. In 1990s, millions of American General Motor V8 engines were completely dependent on a tiny piece of brass forged in Chennai. You see, car engines get incredibly hot. To stop them from melting, they use liquid coolant. And a radiator cap acts as a high-stress thermal safety valve to keep the liquid from violently overboiling. In the past, GM's European suppliers were cutting these caps from solid metal, but humans make mistake. If the caps was off by even a millimeter, the pressure would escape and the engine block could crack. Sundaram Fasteners solved this by throwing away the metal cutting machines. Time for quick chassis code reveal. The owner of Sundaram Fasteners is Suresh Krishna, and he is the grandson of TV Sundaram, the visionary entrepreneur who laid the foundation of TVS Group, one of the largest and most trusted two-wheeler manufacturers of India. They perfected powder metallurgy. Instead of cutting, they compressed fine metal dust particles under extreme pressure and baked it. This created millions of identical, perfectly shaped caps without the imperfections of traditional cutting. They won GM's Supplier of the Year award for 5 consecutive years. They literally kept America driving. Moving outside the engine, let's talk about something that will completely change how you view your daily commute. We all know the terrifying feeling of changing lanes on a highway and suddenly hearing an unseen car horn in the blind spot. For decades, the only solution was physically turning your head, taking your eyes off the road and praying you didn't hit anyone. But today, your car watches blind spot for you. This is possible with those sleek LED turn signals and camera-based blind spot systems built right into the side mirrors. And the craziest part is, they weren't invented in Germany, Spain or USA. This was patented by an Indian automobile giant named Samvardhana Motherson Reflectech. SMR wasn't built from scratch. In 2009, they acquired Visio Crop, one of the German's leading rear-view mirror manufacturers. So, practically no, India didn't invent this technology. But technically, after an Indian company acquired the business behind it, we are calling it a win for India anyway. In late 90s, automakers desperately wanted to put safety cameras inside aerodynamic side mirrors. But there was a massive problem. Computer circuit boards were rigid and flat. You couldn't fit a flat board inside a beautiful curved mirror without making the mirror huge and ugly. Motherson achieved the impossible. They patented the use of flexible circuit boards that physically bend to the curved parts of the mirror. It was a massive breakthrough. They became the first in the world to introduce camera-based blind spot detection for Volvo, saving countless lives on the highway. Today, Motherson controls a staggering 22% of the global passenger car rear-view mirror market. And this knack of brilliant architectural problem solving even extends to German motorcycles. In the past, entry-level motorcycles felt costly and handled poorly. BMW wanted a bike that handled like a premium track weapon, with remaining highly cost-effective. Their solution was the G310 series, but its entire mechanical soul was co-engineered and manufactured by TVS Motor Company in Hosur, India. The engineering breakthrough was a unique reverse inclined engine. By facing the intake forward and exhaust backward, they drastically shifted the bike's center of gravity forward. Normally, a bike's engine takes air from the rear, while the exhaust comes from the front and travels through a long pipe to the back. In a reverse inclined engine, it's exactly the opposite. The air enters from the front and the exhaust exits from the rear. This means a shorter exhaust pipe, less metal, lower weight, and more space for engineers to work with. This brilliant layout allowed the engineers to create longer rear swing arm with a shorter wheelbase, maximizing cornering grip. It was an absolute masterclass in mechanical layout. This ability to rethink the rules from the ground up is known as frugal engineering, and the ultimate blueprint for frugal engineering was the Tata Nano. In the past, cars were just too expensive for an average family in emerging market. People remember the Tata Nano as the world's cheapest car, but legacy European automakers secretly studied it because it was a goldmine for intellectual property. The Nano generated over 30 designs and technology patents to hit that price point. They patented a hollow steering column to cut weight. And most shockingly, they replaced heavy steel welding with aerospace-style structural adhesives and glued the body panels together with advanced epoxies, slashing manufacturing weight and distributing structural stress far more efficiently. And when you master this kind of efficiency, you start building global monopolies. Look at the Bajaj RE rear engine passenger architecture. Before this, three-wheeler existed, but they couldn't handle the harsh reality of the developing world. Today, the Bajaj RE is the blueprint for the last mile public transit in over 36 countries. To navigate in severely degraded roads and tight urban corners, Bajaj engineered a highly compact single-piece frame. By perfectly balancing the powertrain and passenger weight directly over the rear axle, they achieved maximum traction and microscopic turn angles. It is the robust foundation of urban microtransit around the globe. But as we look to the future, the modern car is no longer just a mechanical machine. It is a rolling server. A modern vehicle contains over 100 million lines of codes controlling dozens of computers. And this is where India's digital architecture takes complete control. After all, India has no shortage of software engineers. Finding one is often easier than finding a parking spot. In the past, car software couldn't be tested until the physical computer chips were actually manufactured. If a bug was found late, it cost billions of dollars and delays. KPIT Technologies pioneered a concept called left shift virtual validations. Time for quick chassis code reveal. KPIT Technologies was founded by two chartered accountants, Ravi Pandit and Kishore Patil, not software engineers. Today, the company develops advanced software for electric autonomous vehicles and software-defined vehicles used by some of the world's biggest automakers. Sometimes, understanding business is just as powerful as writing code. They built a digital twin for cars' entire electronic architecture in an Indian cloud environment. This allows global automakers including BMW and Ford to crash, debug and test autonomous driving algorithms months before a single piece of steel is ever stamped. This saves them estimated $8 to $12 billion annually per project. And as the world transitions to electric vehicles, Indian deep tech is already shattering global monopolies. Long before Tesla popularized EVs, the best-selling highway-capable electric vehicle in the world was engineered by an Indian startup. Early electric cars suffered because heavy lead-acid batteries severely limited their range and made them dangerously sluggish. The Reva I proved the viability of urban micro EVs to the Western market. By developing a proprietary energy management system and a lightweight steel frame, they solved the heavy battery problem of early 2000s. Today, the challenges are geopolitical. Nearly every EV uses a motor relying on rare earth metals tightly controlled by China. To break this global chokehold, Indian engineers at Vimag Labs figured out how to delete the permanent magnets from a motor entirely. Using standard copper coils and highly complex suite of a software algorithms, they generate a virtual magnetic field. It matches the power of rare earth metals using pure software. And for the mechanical side of EV, Sona Comstar in Gurugram perfected laser welding and warm forging technology. In a traditional gas car, the loud engine hides the sound of grinding gears. But EVs are silent. The electric motor delivers massive, instantaneous torques which creates high-pitched sound. So from now, if you hear high-pitched sound, it's not electric car passing by, it's a mosquito. Sona Comstar deleted heavy metal bolts entirely. Instead, they used robotic lasers to fuse differential together. The result was absolutely silence under massive electronic torque loads. They now hold nearly 9% of the global market share in battery EV differentials. But perhaps the most dramatic proof of the invisible Indian architecture takes us back to the monster trucks. When a 12,000-pound heavy truck falls from 30 feet in the air, the immense kinetic energy is entirely absorbed by a 645-pound rubber donut engineered in Mumbai. Balakrishna Industries Limited or BKT engineered the FL354 tire. It operates at shockingly low PSI of 23. The proprietary polymer allows the sidewall to compress by over 50% upon a massive impact without blowing off the rim. It is a paradox of mechanical physics, and the BKT holds a clear monopoly on global stadium because of it. So next time you see an European luxury sedan glide silently down the street or a monster truck survive the impossible jump, remember what is actually keeping them moving. It isn't just heavy metal, it's an invisible global architecture of software, metallurgy, and frugal engineering designed in India. If you want to discover the hidden mechanisms of the world around us, visit my channel once a week. Till then, goodbye.